my colleague Andonis has said, I will cover the Raspberry Pi basics as well as a very short description of Python. Starting with the Raspberry Pi. Raspberry Pi is basically a single board computer that is used for professional and educational applications. It started as mainly for education, but people started using them for projects, either professional or on their own. So it became widely applied across the world. Its operating system is based on Linux, specifically on the Debian distribution. Since we covered Arduino yesterday, I decided to do a short comparison between Raspberry Pi and Arduino to see which device best suits different situations. Raspberry Pi, as I said before, is a mini computer compared to Arduino, which is a microcontroller. It is on average more expensive than Arduino, starting from €5 ranging to 75, with the Raspberry Pi 3 being around the 30-something euro range, while Arduino goes from €2 to €100 for the very top end Arduino, but usually you can get Arduino for very cheap. Raspberry Pi requires external storage in the form of SD cards, while Arduino has an internal storage, but it's only 16 kilobytes for standard. Raspberry Pi has higher power requirements, specifically when it comes to current, but it can connect to multiple devices, unlike Arduino, since it's a mini computer. As far as setting up the boards goes, Raspberry Pi has a more complex setup since it's a computer. The Raspberry Pi org has installers that make it a lot more easier to set up the device, but it's still more than Arduino, since Arduino, all you need is basically the environment and the libraries, while Raspberry Pi, you need to install the software, the operating system, the libraries, and so on. Raspberry Pi has a longer boot than Arduino, since Arduino, you just plug it in and it starts running the code. And the other problem with Raspberry Pi is it's an operating system. You have to shut it down to avoid file corruption, unlike Arduino, which you can't just open close. For programming, though, Raspberry Pi allows us to do a lot more than Arduino, because a computer, it can run a lot of programs at the same time, unlike Arduino, which can only run a single program at a time. This means that the Raspberry Pi can also handle programs that require threading, which means running multiple functions or executions at once. Raspberry Pi has a wider support of programming languages. Basically, it supports any language for Debian, while Arduino is basically constricted to Arduino, C++, Python, Blog, and maybe some other languages that provide Arduino support. Raspberry Pi, since it uses an SD card, has a lot more local storage than Arduino, which means it can handle running a lot larger programs, saving the memory a lot more information. And also, Raspberry Pi has higher processing speed than Arduino, but because it has a lot of programs running at the same time, it is not consistent. The speed is not consistent, unlike Arduino, which is one program, you run it, so it is consistent speed, so you do not run into timing issues. As far as general purpose input-outputs go, Raspberry Pi has end-to-end network stuff. Raspberry Pi has a native connection for Wi-Fi, Ethernet, and Bluetooth, while Arduino requires additional add-ons for network connections, at least for most models. Raspberry Pi has for GPIOs, Raspberry Pi has a standardized 40 pins, which you can increase with special add-ons. The standard 40 pins are the digital pins, PWM, I2C, SPI, and UART. So if you need other styles such as RS485, analog, and such, you will need special add-ons. Arduino has pin numbers vary from board to board. Usually they're less than Raspberry, but there are more specialized boards that have a lot of pins. Some will have like 80 pins on them. Baseline Arduino has more variety on pins because a lot of Arduinos come with analog inputs as well, which Raspberry Pi does not have. So in conclusion, Raspberry Pi is on average more complex, more expensive, and requires more add-ons than Arduino, but it offers a larger versatility in terms of programming, and it can also be used for a lot more complex systems. While Arduino, since it's a fast, it's a quick setup, it's consistent, it is better for a simpler system. For the tutorial, we're going to run with Raspberry Pi. We are going to be using this SenseHat, which is an add-on for Raspberry Pi that is mainly used for education. It was developed by Raspberry Pi for the Astro Pi, which is what we'll be using later in the demo. It includes a 9-axis IMU, which is a inertial measurement units, which means it includes 3 sensors called the gyroscope, accelerometer, and magnetometer. It includes a temperature and humidity sensors, pressure sensors, and an 8x8 RGB LED matrix, which is used to display, you can use to display images or words. And it also has a 5-directional joystick in case you need it. Now we'll go into more detail on the sensors on the SenseHat. The gyroscope is basically used to measure orientation and angular velocity of the device. It uses all 3 sensors use 3 degrees of movement on the XYZ axis. They just measure what they're supposed to measure on those axes. The gyroscope has a value range of 0 to 360 degrees. 0 being when it's on rest, and the higher the term, the higher the degrees, up to the 360. As for the accelerometer is used to measure the force of acceleration during motion. So when you're moving the device, it will increase the measure shown. The measure is also on XYZ axis and is measured in meters per square second, or G forces, which is gravitational forces. Basically, gravitational forces is every 1 G force is 9.8 meters per second squared. So you will usually see these two used interchangeably. As for the magnetometer is used to measure the strength and direction of a magnetic field. The magnetic fields are usually measured in units of Tesla, specifically micro Tesla. And how it works is the closer you move a device to a magnetic field, the higher the value of the XYZ axis it will show. It's usually more muddled. Unlike gyroscope and accelerometer, XYZ measures are usually a bit more muddled. They are a lot closer together, so you will need to separate them. As for the pressure sensor is used to measure the atmospheric pressure in the air, basically. It is measured using pascals, more commonly. And in more specific cases, millibars. Millibars is used mostly for meteorology. So in most cases, you will see PA as the unit of measurement. It includes a temperature sensor, which is basically like a thermometer. A temperature sensor measures the temperature through an electric signal. The sensor can measure the temperature in Celsius or Fahrenheit. You just switch between them in the programmatically. And the last sensor is the humidity sensor. The humidity sensor measures the amount of water vapor in the air. The specific humidity sensor in SENSCAD and in most electrical humidity sensors is it measures the relative humidity, which is the percentage between the actual amount of suspended water vapor to the maximum suspended water vapor that could maintain at a given temperature or pressure. Now that we've given a brief explanation of the Raspberry and the SENSCAD that will be used in the demo, I'm going to give a brief overview of what Python is. Python is an object-oriented, high-level, general-purpose programming language, similar to stuff like C, C++. Python is focused on simplicity. It is very simple syntax and indentation compared to most other high-level programming languages. Python, considering the, as we said, simplicity, is very easy to run on other systems. It only requires the language and the needed libraries. Python does not require compiler, and sometimes it doesn't require an interpreter either. And for memory, it uses garbage collection and dynamic memory allocation for more efficient memory management, which means it avoids fewer memory leaks. This is very relevant for small memory applications, but in bigger computers that doesn't really that much. So this was it for the presentation. Thank you for your time. If you have any questions, I will gladly answer them.
Thank you.